this and this. So both the statements are true in this case. So disjunction is true. Here this is false, but this is true. We need only one of them to be true, at least one of them to be true for the disjunction to be true. Here this is true, false, so true. Here this is again true, false, so true. True, false, true. False, true. Here, however, both x and y and z are false. In this case, disjunction is false. Here also, again you see that in these three cases, both the statements x and y and z are false. So their disjunction is false in each of these three cases. Now we come to the individual disjunctions, x or y. X or y is true if either x is true or y is true or both are true. So here we have true, true, so true. We can speed up the let us not speed up the process. It's not about speed, it's about accuracy. Because I may also make some mistake, and since you cannot interact with me in real time, you cannot say that I have made a mistake. I have to be careful. So these two are true, so this is true. Oh, sorry, what am I saying? This is true, this is true, so this is true. True, true, true. Remember, we are dealing with disjunction. So we need at least one of them to be true. True, false, true. True, false, true. False, true, true. False, true, true. Now both of them are false. So disjunction is false. Here also false. Similarly, if we look at this disjunction x or z, we get t. So truth, true, false, true, 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 false, false, true. So these four will be true. Now false, false is false. False, true, true. And false, false, false. Now for these two columns, we have to consider their conjunction, their AND. Okay. Now AND is true only when both the statements are true. One of them is false and it becomes false. So both the statements are true, true, true. We have true, 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 again true, here also true, true, true. Now one of them is false. In this case, one of them is false, so we have false. Remember, this is AND, not OR. This is AND. Here both of them are false, so it's all the more false. Okay. Now, although I don't have space for writing a column for this final one, but we can see that we just have to see that whether these entries are the same. See? They are same. True, true. And in the last three cases, they turn out to be false. Both of them. That doesn't matter. What matters is that they are either both true or both false in these last three cases. That means this and this are logically equivalent. So that this constitutes a proof of one of the distributive laws. Okay. So like that you can also prove the other distributive law. Okay. Two more I want to do. Distributive laws involve three statements, so the truth table is so huge. For others, however, it will not be that big. Okay, so I want to also prove the two more I have said. No? So this I am leaving. It's very easy. You can try it yourself. The law of double negation. But the law of exclusive middle, because it does not involve if and only if I want to do it here. This one is always true. We have to see this. Okay, so here also we are going to form a truth table. It won't be that big. It will have only 3 columns. One for x, one for its negation.